Hello, so we are going to start about CAT 25 99 percentile and welcome from the career launcher. We are going to talk about geometry, quadrilaterals in today's session. My name is Shashank and let's start. So basically what are quadrilaterals? So if you see in the previous session we have talked about what are polygons. So polygons are closed figure with n number of sides, and what what are quadrilaterals? So I can say quadrilaterals are uh, polygons where n equal to 4. So polygons are closed figure with 4 sides, right? So what is the sum of internal angles of quadrilaterals? That is 360. Sum of external angles, that is going to be 360, because sum of external angles for any type of polygon is always equal to 360 degrees. We have already done it in the previous session. Okay, so sum of internal angles is 360, sum of external angles is 360, number of diagonals is given to us. Number of diagonals is given to us as 2. So quadrilateral has 2 diagonals. Okay, so now what we are going to do, we are going to talk about variety of the polygons, variety of the quadrilaterals. The first quadrilateral that we are going to talk about is going to be square. What is a square? What are the properties? So square is a four-sided polygon. So and it is a regular polygon. Now what is a regular? So regular means all sides are equal, all angles are equal. So this side is A, this side is A, this side is A, as well as this side is A. Okay. All angles are equal means all angles are 90, 90. So I am simply drawing the diagonals. Okay. So perimeter of quadrilateral is given, square is given by 4A. Area is given by A square. And this is A, this is A. You can calculate the length of diagonal by using Pythagoras theorem, that is A root 2. So A can be said as D upon root 2. So area can also be said as D square upon 2. So that is the area of square. Okay. Now what is the important property? When you draw the diagonals, they bisect the angle. So this angle is going to be 45, 45, as well as they bisect the diagonals, and diagonals are perpendicular to each other. So angle between diagonals is always going to be 90, and this is going to be the midpoint of a diagonal. That's the important property. And angle between diagonals is 90. Again, remember, this is also an important property, that angle between the diagonals is always 90 degrees. So basically, this is the basic property of squares. Now let's talk about rhombus. Now, what is a rhombus? So rhombus is like, try to understand this. This is a square, right? If I keep the base fixed and I put a force over here, so you are going to get a little distorted figure like this, right? Now this shape is called as your rhombus. So if you see the in rhombus, all sides are equal, but length of diagonals is not. Length of diagonals has changed. So generally we draw the rhombus like this. If you see, the shape of the rhombus is always given like this, and I'll tell you why. So in rhombus, all sides are equal, a, and the perimeter of rhombus is given as 4A, and let's say this diagonal is D1, this diagonal is D2. So the area of the rhombus is given by half D1, D2. Okay. Okay. Now, important point is diagonals bisect each other, means this should be the midpoint of both the diagonals, as well as angle between diagonals is 90 degrees, means angle between both the diagonals is always 90 degrees. Now what is the second property? When you draw the diagonals, diagonals also bisect the angles, means this angle must be equal to this angle must be equal to this angle must be equal to this angle, and this angle must be equal to this angle. So all both the diagonals bisect the angles, opposite and next property is opposite angles are equal. Means this whole angle must be equal to this whole angle. So let's say this is 60, this should also be 60. So opposite angles are equal and adjacent angles are supplementary. Opposite angles are equal and adjacent angles are supplementary means this angle plus this angle should be equal to what 180 degrees. So if this is 60, then this angle is going to be 60, this should be 120, this will also be equal to 120 degrees. So that is all about the property of rhombus. Okay, so this is a rhombus. Now let's look at another shape, another quadrilateral, that is third one. Let's call it rectangle. Now, what is rectangle? So, rectangle is similar to square, right? And how it is different from square. So, basically, rectangle is like this. Everyone knows what is rectangle. This is A, this is A, this is B, this is B. This is 90, this is 90. The perimeter of rectangle is given by 2 times A plus B. The area of rectangle is given by A into B. And when I draw the diagonals, it is the length of diagonal I can calculate by using Pythagoras theorem, that is root of a square plus b square. Now listen to this very carefully. When I look at the intersection of diagonals, that is the midpoint of diagonals. Means this length must be equal to this length must be equal to this length. Same as a square. But how it is different? In square, the angle between diagonals is 90 degrees. Here, angle between diagonals is not 90 degrees. What if you say, what if this angle is 90 degrees? If you get this angle is 90 degrees, then you can conclude that A equal to B, or this is a square. As well as this angle is not 45. In a square, if you see diagonals bisect the angles, so this angle is 45, this angle is 45. In rectangle, this angle, these two angles are definitely not equal. What if this becomes 45? If this becomes 45, you can again conclude this is square. So in rectangle, where A is not equal to B, this angle will never be 45, as well as this angle will never be 45. Always remember this. Okay. अब आगे आते हैं rectangle के बाद. So if anyone has any doubt, kindly drop a message in the comment box or chat box. I'll pick up your query and respond accordingly. And the next shape is parallelogram. Now, what is parallelogram? Parallelogram is similar to rhombus. Parallelogram is similar to rhombus. That angle between the sides is not 90 degrees. This is A, this is B. Sorry, this is A, opposite sides are equal and parallel, A, B, B. So perimeter becomes what? Perimeter becomes 2 times A plus B. Okay. What is the area? Okay. So before coming to area, I'm just going to draw the diagonals. So parallelogram has properties similar to rectangle. Like in rhombus, when you draw the diagonal, they bisect the angle as well as they bisect the angle, and angle between them is 90. In parallelogram, diagonals bisect each other. Means this is definitely the midpoint, right? But angle between them is not 90. If this angle becomes 90, you can conclude A equal to B, it is a rhombus. You can't conclude it is a rectangle. You can conclude it is a rhombus. As well as opposite angles जो भी हैं, opposite angles are equal, means this whole angle is going to be equal to this whole angle, and this angle and this angle are going to be supplementary. So basically this is the property of parallelogram. Okay, now this is a triangle. If I draw the perpendicular, let's call it H. So area of this triangle is going to be half into B into H. So area of parallelogram comes out to be B into H, that is twice of half into B into H. So area of parallelogram is the base into perpendicular distance between both the sides, and that's how we get the area of parallelogram. ठीक है, आगे चलते हैं. The next and most important polygon we have, I think I missed out this, that is trapezium. Trapezium is very important. So what is it trapezium? So trapezium is said to be a polygon that has one pair of sides that is parallel. That has one pair of sides parallel. So this side is parallel to this side. Okay. I'm joining the diagonal and let's call it side as A. Let's call this side as B. And perpendicular distance between both the sides, both the parallel sides is h. So area of this is given by half into distance between parallel sides into sum of parallel sides. So this is trapezium. Okay. Now what we are going to do, okay, let's give it a name: A, B, C, and D. Height is h. Area of triangle ACD is equal to area of triangle BCD, because height is same, base is same. Okay, this is what we know. Okay, now if you see, this triangle is common in both the triangles. मतलब ये वाला जो ट्रायंगल है वो दोनों ट्रायंगल्स में कॉमन है. तो अगर मैं इसको हटा दूं, so what I'm going to get, let's give it a name O. So area of triangle AOD must be equal to area of triangle BOC. And that's it. So basically area of this triangle is always equal to area of this triangle in any given trapezium. We can always say that. ठीक है. ठीक है. If it is, what if trapezium is isosceles? If trapezium is isosceles, it means this side will be equal to this side and nothing else. ठीक है. So these are the basic properties of basic types of quadrilaterals, and these are the basic properties of quadrilaterals. Now let's look at few questions of CAT and see what is the approach. Now this question says the in a parallelogram ABCD, area is 72. In a parallelogram ABCD, area is 72 and sides CD and AD has line length as 9 and 16 respectively. Okay, so AD has line as 16, CD has line as 9. Okay, so what we can do, I am going to draw a trapezium like this. This is C, this is D, this is A, this is B. This is a parallelogram I am drawing. The area of this is 72. CD is 9, this is 9. AD is 16, so BC will also be 16 because it is a parallelogram. Let P be the point on CD such that AP is perpendicular. So I'm drawing the perpendicular from A to this. Okay. So this is P. Now what do I need to do? I need to find out the triangle of APD. क्या होगा, कैसे होगा, देखते हैं. Now area is given to us as 72. What is the area of so I am going to draw the this is AP. So basically this is something like this. Let's say BQ. What is the area of parallelogram? That is base, that is 9, into height, that is BQ, and that is equal to 72. So BQ comes out to be 8. Okay. So if BQ is 8, then AP is 8. AD is 16. I need to find out DP. How I'm going to find out DP? By using Pythagoras theorem. So 16 square is equal to 8 square plus DP square. So from here, 16 square is 256 plus 8 square is 64 plus DP square. So that will give me DP square is 192, and that is equal to कितना आएगा 24 into 8. This is 24 into 8 or 16 into 12. Okay, so DP comes out to be 16. DP square is 16 into 12 square root. So that is going to be 4 to the 8 root 3. So I got this length as 8 root 3. So what is the area? That is going to be half into base is 8 root 3. Height is what? 8. So this comes out to be what? 32 root 3. So answer of this question is going to be option A. So this is how we can solve this question of parallelogram. The basic concept, basic formula. If you remember all the basic concepts and basic formula, you can easily solve these kind of questions. Okay. Now let's move on to the next one. What does it say? Point EFGH lies on the side of ABCD. Okay, AB, BC, CD, and DA, respectively. Okay, and EFGH is also a square whose area is 6. Okay. Mm, let's solve this. Okay. So I am drawing a square ABCD. Okay, okay. So this is A, this is B, this is C, this is D. Okay. It says CG is longer than EB. Okay. So EFGH is square. Okay. So basically EB, CG is longer than BE. So E is the point on AB. So E is here. G is lying on what? CD. Okay. So that is here. Next point is here. Next point is here. So I am going to get a square like this. This is a square. Okay. So E lies on AB. So this is E, F, G, and H. So in geometry, try to draw the figure as good as possible. Now, what does it say? It says that EFGH is also a square whose area is now 62.5%. In fraction can be called as 5 by 8. So if ABCD has an area of 8, then EFGH has an area of 5. And from that, I need to find out the length of EB, that is this, is to CG, that is this. So I need to find out this ratio. Okay, fair enough. So what I am going to do, so I am assuming area of ABCD is 8. So side of ABCD is going to be 2. So this total length is going to be 2. Okay. Now area of this square is 5. So this length is going to be root 5. Okay. Now what is going to happen? I am going to assume this side is x. So this is also going to be x. This is also going to be x. This is also going to be x. And this is going to be 2 root 2 minus x. Okay. Now what I can do? I can simply use Pythagoras theorem. So if I'm going to use Pythagoras theorem, what I'm going to get? I'm going to get x square plus 2 root 2 minus x whole square is equal to root 5 whole square, that is 5. So x square plus 8 minus 4 root 2 times x plus x square is equal to 5. Okay, so I am going to get 2x square. And what I am supposed to find out? I am supposed to find out EB is to CG. So my job is to figure out the value of 2 root 2 x upon 2 root 2 minus x. Okay, okay. So 2x square minus 4 root 2x plus 13, and that's equal to 0. Okay. So, sorry, it is going to be 3 only. So this is going to be 3. So I can factorize this. X square, 2x square minus 3 root 2 x plus, minus root 2 x plus 3, and that's equal to 0. So root 2x is common. Then I'm going to get root 2x minus 3 minus 1 root 2x minus 3 equal to 0. So from here I am going to get root 2x minus 1 into root 2x minus 3, and that is equal to 0. So I am going to get two values of x, 1 upon root 2. Second is 3 upon root 2. So there are two possible values of x. I am going to plug in first value. So 1 upon root 2 upon 2 root 2 2 root 2 is, I can say it is 4 upon root 2 minus 1 upon root 2. Root 2 cancels out. Value comes out to be what? 1 upon 3. That looks like a feasible answer. Okay. Now I'm going to plug in another value, that is 3 upon root 2 upon 4 upon root 2 minus 3 upon root 2. So from here I am going to get the value as 3:1. Now question is saying that CG is longer than EB, so my ratio should be lower upon higher. So it means this value cannot be accepted. So my answer of this question is going to be option 1, that is 1:3. So this is a question of simple Pythagoras theorem, nothing much in the questions of geometry. A lot of times we are going to use only Pythagoras theorem and nothing else. Now let's move on to the next question and see. From a rectangle ABCD, the area of 768 square centimeter, a semicircular part with diameter AB. Okay, so what does it says? I need to cut out the area. So this is a perimeter. This is a rectangle. Okay. Now this is A, this is B, this is C, and this is D. This is cut out. This is cut out. This is, and this has an area of 72 pi. Okay. So if half the circle has the area of 72 pi, so total circle is going to have an area of 144 pi, right? So I can say R is equal to 12. So this length comes out to be 24. Okay. And total area is 768. So 24 into AD is going to give me 768. Okay. 24 threes are 72, and it is going to be 2. So AD comes out to be 48. Now question is talking about the perimeter of the leftover portion. Sorry, this comes out to be 32. So if this is 32, this is 24, this is also going to be 32. So overall perimeter is going to be this plus this plus this plus this. That is going to be perimeter. So 32 plus 32, 64, 64 plus 24, 88. So my answer should be 88 plus something. That is only option D. I don't need to calculate anything else. Because only one option has the value as 88. So directly I can mark the answer as 88 plus 12 pi, because this perimeter of the circular portion should be in pi. So 88 plus some pi. So that is going to be option D. That is 88 plus 12 pi. Now let's move on to the next one. What does it says? That the sum of perimeters of equilateral triangle and rectangle is 90. The area T of the triangle then and area R of the rectangle have a relation of T square. Okay. The sides of the rectangle are in the ratio of 1:3. So I'm just going to have one rectangle. So let's call it A, let's call it A, let's call it 3A, let's call it 3A. So what is the total perimeter we have? 8A. Okay. And equilateral triangle has a side as what? Let's say it has a side as B. So perimeter comes out to be 3B. Okay. Now it says that area of rectangle R. Okay. So area of rectangle R is 3A square is equal to and area of triangle T, that is going to be root 3 by 4 times B square. Okay. So this is equal to square of this. So from here I can say 3A square is equal to what? 3A square is equal to 3B power 4 upon 4. So 3 cancels out. So I can say A square is equal to B square, B power 4 upon 4. So A comes out to be B square upon 4. Okay. B square upon 2. and it says that this is 90. Okay, so total perimeter is 90, means 8a plus 3b is equal to 90. So 8a is what? 8a, 8 times b square upon 4 upon 2 plus 3b, and that's equal to 90. Okay, so this comes out to be 4. So I am going to get 4. So take b common, 4b plus 3, and that's equal to 90. Okay, so I can see this number is a multiple of 6, it is a multiple of 9, it is multiple of 10, it is multiple of 15. So let's try to put something in. So let's take, I'm going to take random value, b as 3. So 12 plus 3 is 15. No, I need to increase the value. So b is 4. So 4 into, this is 16 plus 3, 19. Okay, no. Let's take b as 5. Okay, so this is 5, and it is 5 4s are 20, 23. So am I missing out something? Some of the parameters. Parameter is 8a. A has come out to be, area is 3a square. Area of equilateral triangle is root 3 by 4 times b square, and this is the relation. So 3a square is equal to 3b power 4. Okay, I made a mistake over here. It shouldn't be this. It should be 4. This should be 4. So this should be 4. So it is going to be 2b. Okay. So if b is 3, then it is going to be 9. Okay. So I need to pick a little bigger value. So b is 5, then it is 13. Okay. Not very true. If it is 6 into 15. So it means I know the value of b is 6. So I can say a is equal to b square upon 4. So 36 upon 4 will give me 9. So this side is 9. So this side is going to be 27. So longer side is definitely going to be 27. And that's how I can get the answer of this question. Instead of making quadratic, solving that, just go with hit and trial. That is one of the approaches to solve this question. Now, the second approach is going to be, if I can play around a little bit with the values. So if larger value 3a is 18, then a is 6. So I can just, so area comes out to be 18 into 6. From there, I can figure out the value of b and check the perimeter. So even if I do that, I can still get the answer easily. So using options can be an alternate approach to solve this question. Now let's move on to the next one. What does it says? It says in a trapezium, okay, ABCD. So in a trapezium ABCD, AB is parallel to DC. Just a moment. In a trapezium ABCD, AB is parallel to DC and BC is perpendicular to DC. So let's, and DC is 5, BC is 4. Okay. So this is C, this is B, BC is 4, and let's call it D, and this is 5. Okay, DC is 5, BC is 4, BC is perpendicular to CD. Okay, angle BAD is 45 degrees. Okay, so basically it is going to look like this. This angle is going to be BAD is 45. So basically this angle is 45. The question is talking about what is the area. Fair enough. So what I can do, this length is 4, so this is going to be 4. This is 5, so this is going to be 5. This is 90 degrees. It is 45, it is 90, so this is also going to be 45. What is the area of the rectangle? That comes out to be 20. This is 4 because it is 45, 45, 90 triangle, so this is 4, so this is also going to be 4. So what is the area of triangle? This APD, that is half into 4 into 4, so that comes out to be 8. So area of rectangle is 20, area of triangle is 8. So overall area of the trapezium comes out to be 28. So this is the approach that can be taken to solve this question. Now let's move on to the next one. It says side AB and CD of a trapezium ABCD are parallel, AB being smaller side. This is A, this is B, and okay, so basically we have something like this, C and D. Okay, P is the midpoint of CD. This, let's call it P. Okay, if the difference between the areas of parallelogram, okay, so what I am doing, A, B, P, and D. So I'm joining this. Now I can say this figure is a midpoint. This figure is a parallelogram. That's what question is saying. ABPD is parallelogram. So the by the property of parallelogram, if I draw the diagonal, so basically this is going to divide ABPD into two equal triangles of equal area. Okay. Okay. Now this is the midpoint. So if I look for the height, let's say height is h. So for APD height is h, for BPC height is also h. So and bases are same because P is the midpoint, this is x, this is x. So area of this triangle and this triangle is also going to be same. So area of this is A, area of this is A because they have same base and same height. And area of this is also A because APB is half of the parallelogram. So overall area is going to be 30, sorry, 3A, and that's going to be 30 only because there is only one option that is multiple of 3. But still, let's see. The triangle BPC, the difference between areas of parallelogram ABPD, that is 2A, and BPC, that is A, and this difference is equal to 10. So A comes out to be 10. So 3A comes out to be 30. So I can directly get the answer of this question as 30. Don't have to calculate much, don't need to use a lot of formula. Directly these kind of questions can be solved by basic logic. Understanding the basic properties is important. Remembering all the properties and all those things is important in geometry specifically. With this, we conclude this session. So anyone has any doubt can ask. Thank you.